I just realized that I forgot to do problem number 45, so if you were wondering about that, then here we go. Problem number 45. Where are we at? Hold on. iPad's acting up. Alright, got it. So again, just like the other problems in which we're solving for x and y, we're trying to figure out what the solution to the system is. It's the x and y, the coordinates that satisfy both equations, or the ordered pairs that satisfy both equations. And in order to use our calculator to help us, what we want to do is we want to solve for y in both equations. So this first equation here, solving for y, a couple of ways we could do this. The one that stands out to me is, I don't know why this is, again, misbehaving. The one that stands out to me is if we take the ln of x on the left and rewrite the right-hand side, bringing the exponent, bring this coefficient over to the exponent position, and so we can write the right side as ln of y to the third. Okay, and there's that property of logs that you learned way back when, I don't know when, but you learned it, that if the bases on both sides are the same, then that means that the arguments must also be the same. So ln of x equals ln of y cubed, therefore x equals y cubed, and therefore y equals, if we take the cube root of both sides, or raise both sides to the 1/3 power, we get that y is equal to the cube root of x. So there's our y1, and then our y2, let's see here, so we have 3 to the x equals 3 to the 3y, so 3 cubed to the y, and therefore x equals 3y, and if x equals 3y, then y equals x over 3. So this y, we're going to call y2, is linear, and the other y is the cube root function. And so just based on what we know the cube root of x looks like this, and the linear function y equals x over 3 looks like, oh, I better draw that one better because it's going to hit it at just the right spot. So it's coming up like that. So that's y equals, from the cosmic catalog, y equals the cube root of x, and then we have y equals x over 3, and y equals x over 3 looks like this. So we have two solutions. We have one solution at 0, 0. We have another solution here and another solution here, but we have to be really, really careful because in our original problem we have ln of x. And so since we have ln of x, we can't take a negative solution, and we also can't take the solution 0, 0. So really all we're focusing on here is the solution in the first quadrant. And when I type those two functions into my calculator, I see that x is equal to 5.196, and the y value is 1.732, and that's it for this video.